These are some production micro molding products that were, again, the opposite of the machined mold itself. So in the upper left-hand side, that is a vacuum chuck that's used for a powder inhaler. Those holes are 6/1000ths of an inch. The material itself is a polycarbonate. And so those holes had to be core pins. So you have to kind of think again, that's backwards. So a core pin actually makes the orifice for that molded part, and then the polymer shoots around that, and then the part comes off and gets ejected. The blue part on the upper right-hand side is a P-bax, or a kind of a gummy material, a P-bax flexible catheter tip. So that actual catheter goes through the body and can turn corners fairly easily. It's not rigid, it's nice and comfortable. That catheter tip goes down to a 2/1000ths wall, and you can see there's a good shutoff on there that requires a three-dimensional shutoff at the end, which is challenging to do in steel. The lower left-hand corner picture is and you see the millimeter, half millimeter scale there. That is the same picture that I showed earlier with the penny that has some very small features to create the mold, and that is the electrical connector with some very small holes in it. The lower right-hand side is a microfluidic nozzle that's used for insulin pump delivery. That is a glucose monitor / insulin pump delivery mechanism with a very small 125 micron or 5/1000ths hole in the center. Some other catheter tips here to give you an idea. Right at the end of this white part is an extremely small 2/1000ths of an inch wall thickness, and again, getting something that small, if you were to make that core pin, which makes the hole in the center, offset a little bit, now you're not going to fill those very small thin walls at the end. So it's really important over the length of that P-bax catheter tip that core pin is centered properly to be able to fill that properly.